So today we're going to go over the trigonometric ratios. So by the angle similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with the same acute angle measures. So what does that mean? That means so triangle ABC is similar to DEF is similar to XYZ. So that means our if we look at our AB, or actually let's look at BC, it maps to EF, right? Which also maps to what? YZ. See that? And that means then our AC, first to last, over first to last, DF over first to last, XZ. See that? So a trigonometric ratio is this ratio of the side lengths of a right triangle. And that's what we're going to be talking about, side lengths of a right triangle. Now, when you use these ratios, we're going to designate each side as the hypotenuse, which is opposite the right angle. We know that by now. Adjacent, however, means beside the angle, whereas opposite is opposite the angle. Okay, very understandable. Okay, so let's talk this through. So the sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So this is sine is opposite over hypotenuse. Okay, so if we do the sine of angle A here, opposite is A and hypotenuse is C, so that's why it's A over C. If we do the sine of B, the opposite side is B over, again, the hypotenuse C. Cosine, however, is adjacent over hypotenuse, okay? So if we look at the cosine of C, cosine of A, that's going to be adjacent B over C, okay? Whereas the cosine of B up here is adjacent is A and the hypotenuse is C. Now, tangent is opposite over adjacent, okay? So that's the ratio. So if we look at the tangent of angle A, opposite is A and adjacent is B. So you're never going to have the hypotenuse in the tangent, okay? And when we talk about the tangent of B, it's the opposite over adjacent again. So again, opposite B over A. Notice these flip from each other. You see that? So depending on the angle, they're going to flip over one another. So our next point here is in trigonometry, the letter of the vertex of the angle is often used to represent the measure of that angle. So for example, the sine of angle A is written sine A. And we're going to use that as we go through the lesson. So a lot of people use SOHCAHTOA. So, SOHCAHTOA, SOHCAHTOA, to memorize what the trig ratios are. Sine, opposite of hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent, okay? So, and then some people try to make up a statement to memorize that. So you could say like, some of his cars are, I don't know what. You come up with a statement, okay? Some of his cars, some of his cats, or some of her cats. Y'all got me? So come up with a statement that has all of these letters in it, and that's a great way to memorize SOHCAHTOA. Or just remember SOHCAHTOA, okay? But some of his cats, see, some of his cats are hairy, or something. I don't know. But you need to come up with one that makes sense to you so that you'll remember it, okay? Examples 1A and B and C say find the trigonometric ratio. So we're going to write the trigonometric ratio as a fraction and as a decimal, rounded to 2 decimal points. Okay, so what I'm going to do first is sine is SOH, right? So that's sine, opposite over hypotenuse, opposite over hypotenuse. Okay, so we're going to look at angle J. So angle J is up here, so the side opposite is that 60. And the hypotenuse, this is, you could always label that H because we're always going to know what that is. So that's 60 over 61. And then we're going to compute that on our calculator. So we're going to divide 60 by 61. And when we do that, we get 0.98. Okay? So those are our answers. So now the cosine is C-A-H, right? So cosine adjacent hypotenuse. Okay? So now we're going to look at J again. So angle J, and we're going to leave the H up there because that's going to be applicable again. So this time we're looking at the side that's adjacent to angle J. So that would be this now, right? So angle J, it's beside it. That's what adjacent means. So we're going to put ADJ over hypotenuse again. And that's going to now be 11 over 61, right? And now again, we're going to put that in our calculator, and that's going to give us 0.18, okay? Then we're going to find tangent, and tangent is TOA, T-O-A, okay? That's opposite over adjacent. So we're going to put opposite over adjacent here, and then we're going to find out what that is for angle K now, okay? So when we go to K, opposite now is, if we go straight across there, that's our 11. So that's going to be 11 over what? Our adjacent now is the 60, right? Because it's right beside that K. So that's going to be 11 over 60. That's our tangent ratio. And then we're going to put that in our calculator again, and that's also going to be 0.18. Okay? All right, so now I want you guys to do this. You try down here. So again, remember what sine is, cosine, and tangent. So S-O-H, ka, C-A-H, TOA, T-O-A, okay? Okay, so opposite over hypotenuse of angle A. Go ahead and do it and come back to me when you're done. So again, opposite of angle A is that 7. And hypotenuse is where? That's our H, right? We can leave that like that. So that's 7 over 25. Do that in your calculator, and you should have gotten 0.28, right? Okay, now again, we're talking about angle A, so we're talking about adjacent now, right? So isn't this going to be the adjacent to the angle A? It's right beside it, yes? So this one's going to be 24 over that 25. So this one is going to be 0.96 when we put in the calculator. And tangent, again, is going to be opposite over adjacent. So this time we're talking about angle B, right? So our opposite now is going to be there, and our adjacent is right here beside. So that's going to be our A, and this is going to be our O. Okay, so this is going to be 24 over 7. Put that in the calculator, and yes, for tangents, you can get a number greater than 1, okay? Not for sine or cosine. You should never get a number greater than 1 for sine or cosine. And if you do, then you should know that something's up, okay? Because obviously our hypotenuse is always our biggest side, right? So this is going to be 3.43. All right, so for this next part, we're going to find the trigonometric ratios and special right triangles, okay? So this one says write the cosine as a fraction. So cosine means C-A-H, adjacent and hypotenuse, right? So there's our hypotenuse. And if we're looking at our adjacent angle to the 30, it's obviously going to be the one right next to it. So this is going to be our adjacent here, right? So we're going to do adjacent over hypotenuse. That's going to be the s square root of 3 over 2s. Notice we have an s on the numerator and the denominator, so they're going to cancel each other out, right? So we're going to end up with the square root of 3 over 2. Now, if you guys take the square root of 3 over 2 and do that in your calculator, then you get 0.87. And if you take the cosine of 30, guess what you get? 0.87, okay? So same way here, write the tangent. Now remember, tangent is TOA, right? Of the 45-degree angle. So that is opposite over adjacent, right? So we got opposite over adjacent. So we got 45. Opposite is S. And guess what? Adjacent is also S. So that's going to be equal to 1. So here again, if we take the tangent in our calculator of 45, guess what we get? 1. Okay? So for this next part, we're going to learn how to do this on our calculators, okay? So we're going to do the sine, the cosine, and the tangent. And so we want to make sure our calculators are in degree mode. So what I want you guys to do is go, we're going to go second mode. We're going to click mode, okay? And then you're going to scroll down to where it says radian or degree, okay? And you need to make sure that the degree is chosen, okay? So that's what you're going to do. And you need to always make sure this is in degree mode when you're doing trig, okay? So then, all we're going to do then is actually calculate these. So this is pretty easy, okay? So you're actually going to push the sine button and then 52, enter. And that's going to give you 0. And it's asking us to find it to do 2 decimal places. So this is going to be 79 because it was 788. Okay, then we're going to do the cosine again of 19, enter. Here again, it's 0.95 because it's 945, right? And then we're going to do the tangent of 65. And notice that this is the only one that's greater than 1. So this is going to be 2.14, okay? So go ahead and do the u-tries down here at the bottom, and then come back to me when you're done. So the tangent of 11 in your calculator, where is the sheet of paper? Tangent of 11. I got it flipped over, y'all. Sorry. Was 0.19. The tangent of 62 was 0.88. And the tangent, or the cosine of 30 is 0.87. Okay? All right, so now we're going to use these trig ratios to find lengths. So we're going to find the length of BC, and we're going to round to the nearest hundredth. So what we want to do first is look at this. So like on y'all's paper, it says find the length of BC, round to the nearest hundredth, right? So if we're looking for BC, and we have AC, so we're looking at, we have angle B, right? So there's angle B. So we're going to say something of B, right? So we're going to say the sine of B or the cosine of B. So notice this is opposite B, and this is adjacent B. So what ratio uses O and A? Isn't that tangent? So what we want to find is the tangent of angle B, and that should be equal to our opposite over our adjacent, right? Okay? So what we're going to say is the tangent of the 15 degrees is going to be equal to the 10.2 over our length, which is BC that we're looking for, okay? So now, I want you guys to notice something. You want to switch, when you get to this point and you have what you're trying to solve for in the denominator and the tangent of 15 on the other side, you're going to switch the tan 15 with the BC. This makes the problem a lot easier. So you basically, these swap positions, y'all got me? So now I'm going to say BC is equal to 10.2 over the tangent of 15. Now I can show you why this works, y'all. So let me show you just 1 second. So if I have the tan of 15 equals 10.2, normally I would then multiply over BC. I would multiply both sides times BC, right? Yep, so that gives me BC times tangent of 15. So now that's gone, right? BC is gone from over here, and we just have that 10.2, right? So now how do we get rid of the tangent of 15? We divide both sides by the tangent of 15. So here's the easy. The easy is you just swap positions. When you have the variable you're trying to solve for in the denominator, you just swap it with what's on the other side of the equal sign. Then you're just putting it in the calculator. 10.2 divided by the tangent of 15. So BC is going to be equal to 38.07. And this one says round to the nearest hundredth, right? Okay, it says also, do not round until the final step of your answer. Use the values of trigonometric ratios provided by your calculator. So let's keep going now on this next one. So what length do we have? Okay, so once again, we got the angle here, P, right? So we have, this is the hypotenuse, right? So this is H, and then it's asking us to find QR. So where is QR relative to the angle? Isn't that opposite? So what ratio uses opposite and hypotenuse? That's SOH, right? Sine. So we're going to do the sine of our angle, which is 63, and that should be equal to that QR over our 12.9. So this time it's different, right? Because our variable's in the top, so we're going to multiply both sides by the 12.9 because that's how we get rid of it from the denominator, right? So we're going to do 12.9 times the sine of 63. And again, you can put that in the calculator just like that. So that's going to tell us that QR is equal to 11.49. Okay? So I'd like you guys to try the U-Try 4A. And we'll check it, and then we'll go on and do the next one after that. So again, it's asking us for DF, right? So isn't this the hypotenuse? And look where our angle is. We got the 51. So where is that? Is that adjacent or opposite? Yep, that's opposite. So what ratio uses O and H? SOH. Isn't that sine? So we're going to say the sine of 51 is equal to our 17 over DF, right? So what I tell y'all to do when it's like this, swap places, right? So we're going to say DF is equal to 17 divided by the sine of 51. You can do that right in your calculator, and it will give you the answer. So DF is going to be equal to 21.87. Okay? Do the next one and then come back to me when you're done. Okay, this time it's asking us for ST. So what is the relationship of ST to that angle, 42? This is now adjacent, right? And we still have the hypotenuse. That's another hypotenuse. So isn't that going to be cosine? So that's going to be CAH, CA, right? So we're going to do the cosine of our 42, and that's going to be equal to the adjacent over the hypotenuse, right? So that's going to be our ST over our 9.5. And how do we get rid of something that's in the denominator? You got it. Multiply both sides by 9.5. So here again, we can put this right in the calculator just like that, right? 9.5 times the cosine of 42. And you can actually do 9.5 parentheses cosine 42 or just 9.5 cosine 42. And it will give you the answer. And so this time, ST is equal to 7.06, right? Okay, so our last problem here says find the length of BC. Let me move this out of the way. So BC is down here, and we're going to say, what is the relationship of BC to that angle A? And that's going to be adjacent, right? And this is opposite. So what is that ratio that uses opposite and adjacent? That's going to be TOA, right? So that's tangent. So we're going to say the tangent of 18 degrees angle is equal to opposite 12 over adjacent, which is our BC, right? So what did I say we would do when we have something in the denominator? They're going to swap positions, right? So we're going to say that BC is equal to 12 divided by the tangent of 18. So what does that mean BC is equal to, guys? So BC, go ahead and do that in your calculator. BC is equal to 36.93, right? Okay, that's it.